So the part that we're going to be using for this demonstration is a small single pole double throw switch. It's a little slide switch. You slide between these two positions. It has 3 pins on it. And the main thing that we're concerned about are the dimensional information to start with. Now you could start with a symbol or you could start with the package. It doesn't really matter. But in this case I'm going to just start with the package. So I'm going to make some dimensional measurements here. I'm going to take my calipers, zero it out, make sure the jaws are closed and that they're clean. I'm going to wipe those down and make sure that it's zeroed out. And I'm going to measure first of all the outside dimension here. And I make a measurement of 0.4585. Whoops, 0.4585 inches. Now that's more resolution than we need. Especially for the package outline, we can be within probably 0.005 of an inch. But let's start with that. So I'm going to round this dimension to 0.460 inches. Again, this is going to be the silkscreen dimension we see on the board that shows the outline of the part. So it's not super critical, and I'd rather err on the side of a little bit of a larger value if necessary. Now, the height doesn't really matter. Later on, hopefully if we have time, we can talk about 3D modeling of parts in Eagle. But again, all that we're going to see on the board is the part plugged in this way, flat to the board. So the other dimension I'm going to measure is this one here. And we end up with 0.156. So I'm going to end up rounding that to 0.16 inches. So the next dimensional information that's really important is the pin size, or the lead size, and the spacing of the leads. So let me start with the lead size itself. I'm simply going to measure, try to make sure you get the thickest point, and my lead diameter is about 0.23 inches. Now, we have to be careful about is that is not the largest dimension. The largest dimension on a square pin is actually the diagonal. So it's about 0.035 inches. So the last measurement I need to make here is the spacing between the pins. Now, I happen to know, looking at the data sheet, that it happens to be 0.10 inches exactly. If you wanted to measure that more accurately, or if you weren't sure, if you just had the part on hand, what you could do is measure the outside distance between 2 pins here, and then subtract the thickness of a pin. And that would give you the actual dimension of the space between those 2 pins. But it happens to be 0.1 inches. And this center pin is centered in the package itself. So let me sketch that out. Okay, so now we have enough information to actually create the package for the device. Now, one of the things that's important is that when we look at this dimension here for the pin diameter, again, I measured because it's a rectangular pin, I measured it at a diagonal to make sure I have the largest value. But when we start talking about PCB manufacturing processes, what we'll find out is that for some of the processes it's subtractive, where we etch the material, but then in some cases we're adding electroplating parts. And so what happens is that the actual hole diameter that's drilled on a circuit board, if we had the PCB material and we drilled a hole, what happens is that that hole ends up getting plated on the inside. And that might be a couple thousandths of an inch. So when we're actually trying to define the size of the pad diameter for our part, we're going to oversize this a little bit. I would pick, for example, maybe 0.040 inches. They typically say add at least 0.005 of an inch. And again, the reasoning for that is that if you drilled that hole and it's too small, and then you add material like solder or copper on the inside, it might be so small that you can't even put your pin into the hole anymore. And I've done that before. It's a terrible mistake. You can't just drill it out because you lose the copper coating. So we're going to move now on to Eagle, where we actually look at the next step of creating this package for the component.